Okay, so let's see how you're doing on these so far. So on top, convert to percents. These are decimals that we're converting to percents. Well, decimals or fractions. So to convert 6.2 is a decimal. To convert that to a percent, what do we have to do? Perfect. Times that by 100. We think of 6.2 as being out of 1. So to turn it into a percent, it's got to be out of 100. So we cross, multiply, and divide, or just move the decimal over 2 spots. That's 620 out of 100, or 620%. Remember, 1 would be 100%, so that has to be bigger than 100%. The next one, 11/16, a fraction to turn it into a percent, we use our proportion. So we make it equal 100, and we'll cross, multiply, and divide. 1 times 100 divided by 16 is going to give us what? 68.75 out of 100, or 68.75%. Good. And finally, 0.073 as a percent is going to become 7.3%. Again, times 100, just move the decimal over 2 spots. These next two are a little trickier, turning these percents into fractions, but I didn't give you really nice percents to work with. 18.75% is going to become 18.75 over 100. Any percent, when we convert it to a fraction, is over 100. But we don't want to leave it like that. The first thing we want to do is we want to get rid of the fractions within, or the decimals within our fractions. What are we going to do to get rid of that decimal? There's how many decimal places? 2. So to get rid of 2 decimal places, we have to multiply by 100. So 18.75 times 100 is 1,875. 100 times 100 is 10,000. Both of those can be reduced by how much? Can be divided by 5 will work. So that's going to give us what, 375 over 2,000. And then they can both be reduced by 125 will work. 375 divided by 125 is 3. And 2,000 divided by 125 is 16. So 3/16 is that fraction. Write that bigger so you can read it. 73 1/3 is going to be 73 1/3 over 100. What do we have to do with that? Times by what? Careful. Times by 100 won't get rid of the fraction here. What we have, when we have a fraction, what we're going to multiply by is the denominator. So the denominator there is 3, so we're going to multiply top and bottom by 3. So 100 times 3 is 300. 73 1/3 times 3 gives us what? 220. Both of those can be divided by what? 5 will work. Then in zeros also, so I done maybe 10. I just didn't feel like dividing by 5. You could have divided by 5 and then by 2. You get 22 and 30. We can still divide by 2. They're both even. You still divide by 2. So 11/15. 73 1/3% is 11/15. Is there anybody that's got all 5 right so far? Good. Convert to decimals. Converting to decimals, we're just going from the percent, which is out of 100, to a decimal, which is out of 1. So we're basically dividing by 100. So 2.8% is going to become what as a decimal? 0.028. Good. 364% is going to become what as a decimal? 3.64. Perfect. Any questions on those? Okay. Well, one thing we had mentioned, I mentioned something called benchmarks. And what we mentioned that is when we did 1/4%, and I asked you to turn that into a decimal. And a lot of you said 0.25 right away. But I brought up the fact that if I had 1% as a decimal, it's going to be 0.01. So 1/4 is definitely smaller than 1. So as a decimal, it better be smaller than 0.01. And we discovered that it has to be 0.0025. The 0.25 is the 1/4% still as a decimal. Excuse me. Well, those benchmarks are huge when we're working with percents. In fact, there's a lot of calculations we can do with percents just using benchmarks without really doing anything with the calculations at all. And let me show you what I mean by that. If I start off with 2,800 is my number. What is 10% of 2,800? 280. Very good. Because 10% is 10 out of 100, or 1/10. To find 1/10, it's just a matter of moving that decimal point over one spot. So 10% is simple to find relatively. What would 1% of 2,800 be? Well, 1% is 1 out of 100, or 1/100th. In other words, dividing by 100, which means we just move decimal over 2 spots. 1% of 2,800 becomes just 28. So we can find 10% and 1% relatively simply by moving decimal points. There are other percents that aren't so bad to find, like 50%. 50% is what fraction? Well, 50 out of 100, or 1/2. So 50% of the 2,800 would be, that's half of 28. 1,400, right? 14 or 1,400. 5% is 5 out of 100. You can think of it as 1/20th, but I'm going to look at it this way. 5% is half of 10%. 10% here is 280. What's half of that? 140. With those benchmarks, I can now find a lot of percents out of that 280. For example, let's say I wanted to find 21% of my 2,800. 21% can be thought of as simply being 10% plus 10% plus 1%. That adds up to 21%. Well, 10% we said was 280. There's another 280 for the other 10%. 1% we said was 28. So we add those up, we get 588 is 21%. we get asked to find 49% of 2,800. I'm going to approach this one just a bit differently. I could look at that as though it's 50% minus 1%. That would give us 49%. Well, 50% of 2,800 is half of it, or 1,400. What's 1% again? 28. So we're subtracting the 28 from the 1,400. Gives us 1,372 is 49%. And there are a lot of course, we could have done this a lot of different ways. You could have done 49 as 4 10s, a 5, and 4 1s if you wanted to. In fact, it's not as hard as it sounds. If you look at your benchmarks and your patterns, 4 10s, that's 280, 280, 280, and 280. If you were to add those all up, you're going to get 1,120, right? So that's 40%. To get to our 49%, we also need 4 1s. Well, 4 1s is just going to be 28, 28, 28, and 28. Or 10% of 40, which is 112. So you'd have the 1120, the 112, and 5% would be 140, half of the 10%. $72, not $82. Be at $13.72. So there are a lot of different ways you could break those percents up and build them back up from our basic benchmarks. And now I'm not saying that you need to do this, because there are some that I do. Like 49%, I actually do. If I'm calculating in my head, I will do 50% and subtract 1% from it. I do that quite a bit. Even like 19% and stuff like that, I'll do 20% and subtract 1% from it. But the key to these benchmarks goes back to our first couple of days of class where we talked about having an estimate. If I can look at something and very quickly determine what 10% of it is, if I'm trying to find 13% and I'm punching that in the calculator, I have a pretty good idea of what 10% is. That 13% better be a little bit bigger than it. If it comes out way bigger than it, then we know we're in trouble, or smaller than it, we know there's a problem. So we can use these benchmarks to help stop us from making some very silly mistakes. Okay, enough of that. Let's start looking at our calculations then. When we looked at converting fractions back into percents, what we looked at was a proportion. We had like 3/8. Well, how much is that out of 100? So we solved that by cross multiplying. 3 times 100 is 300. And dividing by the 8, which gave us 37.5 out of 100, or 37.5, or 37.5%. Well, that same type of proportion is going to be used for most of our percent problems that we're going to do. For example, let's say I ask you to find 30% of 90. While dealing with a percent problem, we know that the percent is out of 100. So we're going to start with that percent. 30% becomes 30 out of 100. Now on the other side, all I have to do is match things up. The 30% is what is often referred to as a portion. It is a piece of a whole amount, of a larger whole amount, that we are interested in. somewhere there's another number in this problem that represents that same portion as the 30. The 100 is the base. It is the amount that all the other calculations are being based off of or calculated from. So now up here in the base, or the 100%, is usually the whole amount or the beginning amount, or the starting amount. So we look in the problem, there are two other numbers. One number that's going to match up with the 30, and one that's going to be the whole amount, or matching up with the 100, the base amount. Well, we have the two numbers we have. The 90 is easy to find. The other one, says find 30%. So what we're trying to find is the other number, the missing number. So that missing number, find 30%, implies that the 30% is what we're trying to find. So the number that matches with 30 is the missing number. The 90 over here, of 90, if you think of that as being out of 90, that implies the 90 has to go on bottom, which makes sense if the missing number's on top. So now to find that missing number, we cross multiply and divide. 30 times 90 is 2,700. Divided by 100 is 27. So 30% of 90 is 27. Different way of wording a same problem, or similar problem. Blank is 120% of 60. So again, we have the percent, the 120. So we're going to start with that. 120% is 120 over 100. On the other side now, one number matches up with the 120 and one number matches up with the 100. If we look at this, this is blank is 120. That implies our missing number matches up with the 120. Of 60, we read that as out of 60. That implies the 60 goes down there. So now we cross multiply and divide. 120 times 60 divided by 100 is 72. 72 is 120% of 60. Now some of you at this point might think that looks a little funny because we just got a piece, the 72, that's bigger than what we started with. Why is the 72 bigger than the 60? What's special about a percent? It's more than 100%. 100% would be the whole thing. So if we're bigger than 100%, we're going to get back more than the whole thing. So this next one is a similar problem. It's just going to be worded differently again. %% of 40 is blank. So we have 80% is 80 out of 100. Now we have the other two numbers to match up. Of 40 and is blank. If I'm looking at this of 40, I can think of it as out of 40, implies the 40 goes on bottom. Now you look at 80% is blank, so it's implying the blank matches up with the 80%. So again, we cross multiply and divide. 80 times 40 divided by 100 is 32. 80% of 40 is 32. So far, the three types of problems we have done have all been, or three problems we have done have all been similar types. So now I want to look at one that's a different type. $18 is 60% of blank. So we have the 60%. We always start with a percent. So 60 over 100. On the other side, 18 is 60%. That implies the 18 matches up with the 60. Of blank, we think of that as out of blank. Implies our missing number goes on bottom. So we can cross multiply and divide. 100 times 18 divided by 60 is 30. Now you'll notice that proportion is different than the one up here. But once we match up everything, get everything put in its place, it's still cross, multiply, and divide. Here we were missing the top number on this side. Over here we're missing the bottom number. But it's still, you take the two numbers that are diagonal and multiply them. In this case, the 100 times 18, and then divide by the third one. So that is 30. %20 of blank is 68. So here again, we have the percent. 20% is 20 out of 100. On the other side, what's going to match up? What's going to go on top here? 68, because 20% is 68. So on bottom, it will be a missing number. So we're going to cross multiply. 100 times 68 divided by 20, which is 340. So 20% of 340 is 68. So there's another type yet. We could have 42 is blank % of 70. Here we are missing the percent. And I've been saying all along that we start with the percent. Well, that's not going to change here. Even though it's missing, we're just going to do blank over 100 equals, perfect, 42 over 70. 42 is blank, implies the 42 goes on top. If I think of this as out of 70, implies the 70 is on bottom. So 100 times 42 divided by 70 is 60 out of 100, or 60%. Blank % of 90 is 18. So again, we're going to start off with blank %, blank over 100, equals, well, of 90, if I think that's out of 90, the 90 is going to go on bottom, is 18. The 18 goes on top. So 100 times 18 divided by 90 is 20. So 20% of 90 is 18. 8 questions. Now you notice on this proportion, each time there was a different piece that was missing. This time it was that one, sometimes it was the top one over here, sometimes the bottom one. But every time, once we got everything in its place, it was just a matter multiplying the two that are on the diagonal and dividing by the third. Cross, multiply, and divide. There is another method we're going to look at. It's called the rate method. I prefer the proportion, but the rate method does have its place. And this might be the method that many of you were taught. Using the rate method, you would look at a problem like this and say, okay, 30%, I'm going to change it to a decimal, is 0.3. And then you would take the number 90 times the 0.3, which is 27. Which is the correct answer there. Same here. You take the percent of 120%, change it to a decimal, 1.2. You're going to take your 60 times 1.2, gives you 72. Again, correct answer. Really kind of quick and easy to do. Even this next one, 80%, it's 0.8. Take 40 times 0.8, we get 32. So far on these first three, the rate method has looked a lot easier. The problem with the rate method is when we get to this next one. 60% is still 0.6. But when we go to solve this one, it is not 18 times 0.6. It's 18 divided by 0.6. Gives us 30. Same with this next one. 20% is 0.2. But again, it is not 68 times 0.2. It's 68 divided by 0.2 to give us 340. So when we're doing the rate method, we change the percent into a decimal, but then we have to decide whether we're going to multiply by that decimal or divide by that decimal. In fact, there's even a third type of problem we can run into, like this one, where we don't have the percent given. So we're just going to take the two numbers and divide them. 42 divided by 70 is 0.6. And that's our decimal that we're going to convert into a percent of 60%. So you can see that rate method, it is quicker, but you have to be able to look at the problem and decide, am I multiplying, am I dividing, or am I dividing first and then turning it back into a percent? I want you to try a few in your notes. Blank is 25% of 60. 32 is blank percent of 80. And 56 is 70% of blank. Try those three in your notes quick. So the first one, we have 25%. So we start at 25 over 100. On the other side, where does the 60 go? On the bottom. Very good. So you cross multiply. 25 times 60 divided by 100 is 15. Good. Next, we don't have the percent. So what do? Perfect. Blank over 100. And then 80 on bottom. Out of 80 would imply it goes on bottom. 32 on top. 32 is blank, implies the 32 matches up with the missing percent. So 100 times 32 divided by 80 is 40. So that's 40%. And here, we have the 70%. So I'll put that 70 over 100. What goes on the other side? 56 is on top. So you cross multiply. 100 times 56 divided by 70 is 80. 56 is 70% of 80. Any questions? Okay. Well, what if we had something like this? You purchase an $80 item for your store. You want to sell it with a 30% markup. How much do you charge? In your notes, see if you can figure that one out for me quick. We have 30%, 30 out of 100. On the other side, we have numbers that match up with those. The 30 represents the markup. The 100 represents the starting or the beginning price, the beginning amount. So on the other side, we have the beginning amount, the $80. If we cross multiply and divide here, 30 times 80 divided by 100 gives us 24. Is that what we're looking for? Are we looking for the markup? No, we're looking for how much we charged, which is the original $80 plus the markup, 104. Now we're going to come back and look at problems like this a little bit more in a bit that are percent increase or decrease problems. But you have to make sure that what you're getting out of that proportion is what your answer to your question is. So let's look at one like this. PDM Corporation estimates monthly profit as 18% of net sales. Find the net sales for a month when profit is estimated as $57,600. So we look at this, we've got 18%, which is of course 18 out of 100. What does the 18 represent there? The 18% is what? Yeah, 18% is profit is 18%. So the 18% represents profit. And that profit is figured out as a piece of what? A portion of the net sales. So the 100% is representing the whole amount, or the net sales. On the other side, we have the 57,600. Does that represent profit or net sales? Profit. Profit is estimated at 5,700, or 57,600. So we are looking for net sales, and that's what we're going to get out of our proportion, is net sales. So we cross multiply and divide. 100 times 57,600 divided by 18, which is going to give us 320,000. Perfect. Let's say you have a situation like this. A 4% discount saves you $2.44. What was the full price? I want you to try that one in your notes quick. See what you come up with. We have 4%, which is 4 out of 100. The 4 represents the discount. And the discount comes out of the full price. So the 100 represents the full price, or the full amount. On the other side, we have the $2.44. Which one does that represent? Somebody said it there. The discount. So now we can cross multiply and divide. That comes out to be $61. So full price was $61 before the discount. Pat's gross pay is $640 per week. Pat pays 23% in taxes. How much does Pat take home each week? Take home just means how much is left after they take out taxes. Trying to figure that one out in your notes quick, and we'll come back to it. So we have the 23%, what goes on the other side? The 640 goes on bottom. Now let's remember here, the 23% represents our taxes. The 100 is the gross pay. The 640 bucks. So that's why the 640 has to go on bottom, because it does represent the gross pay. If we cross multiply and divide here, 23 times 640 divided by 100. We get $147.20. Is that our answer? No, that is the amount of the taxes. We're not looking for the amount of taxes. We're looking for how much does Pat get to keep after taxes. So we have to subtract. $492.80 looks to be what Pat gets to keep after taxes. So one of the nice things about using the proportion method is when we do word problems, it's really easy to match things up. And I like to label them like this just to make sure I'm keeping track. The other thing is by labeling them, you know what each number stands for. So when you're done cross multiplying and dividing, you know, is that number what you need to answer the question, or is it something you have to use to figure out something else to answer the question? So I'm going to have you guys try a couple here. So TMJ Inc. runs about 1.2% rejected parts. How many parts are produced in an hour where 1,728 parts are rejected? I'll give you a couple minutes to look at that. So we have 1.2%. That is 1.2 over 100. And the 1.2 represents rejected parts. So 100% must represent all parts. So we want to know how many parts are produced in an hour where 1,728 are rejected. Well, that's rejected is the 1,728. So that goes on top of the rejected. So now we will cross multiply and divide. Giving us 144,000 parts. Any questions? Well, then how about this next one? If Chris has a 4% rejection rate, how many good parts, let's do this, how many total parts does Chris need to produce to create 1,920 good parts? I'm going to have to give that one a shot in your notes quick. So 4% is 4 out of 100. The 4 represents rejects, right? The 100 represents all parts produced, total produced. Up in the problem, however, we have 1,920 good parts. That does not represent either one of those numbers, does it? So what we have to look at is this. When there's a percent, a portion like this, there are always 3% involved. There's the portion that's stated, in this case, the 4%. There is the whole thing, or the base, which is the 100. But the third percent, the one that's not stated here, is the complement. And I'm sure you've all used these before. If you think of a discount, let's say you're going to get a 20% discount. Well, what percent do you pay? 20% discount, you would pay 80%, right? 100%, the whole amount, minus 20% gives you 80%. That's the complement. That's what's left over after a certain percent. So here we have a 4% reject. What percent is good? 100 minus 4 is 96% is good. So what we're saying here is the percent we want to use is the 96%. Because if 4% are rejects, 96% is good out of all 100%. So on the other side, we have 1,920 good parts. That matches up with the 96%. We cross multiply and divide, we have to get 2,000 total parts produced. So we have to be aware of what each number in those percents represent so that we're matching up things that are equal. Too many people make the mistake here that they put a proportion in and they put the 1920 down below. That will not work. Because the 1920 does not represent the 100 amount. The 100%, represents the whole amount. The 1920 does not represent the whole amount. So the 100% is always the whole thing. So you have to make sure that the numbers you're putting in those proportions represent the same thing. Okay, I went about 2 minutes long on our break time here, so let's go ahead and take our break. We'll come back at 4:32.